Today's the 3rd, right?
Yep.
All day. Okay, so chapter 5 deals with polynomials. We can't define polynomials just yet, however, we have to start slow. Slow meaning with what an exponential notation is, although we know what an exponential notation is, but we need to go into more detail. So when we are told or given a to a power, this whole thing is called an exponential notation. And now decomposing it, this piece is called the base, and this piece is called the power or exponent. The exponent. So let's look at a couple of examples. If I'm told 3 to the 4th power, it's not 3 times 4, but this is 3 times 3 times 3 times 3, which is 81. Once this notation was invented, a lot of properties came along. So for example, one property would be a to the nth, this is the general property, multiplied by a to the mth, and you have it right here, or a to the mth times m to the nth is the same thing. So it's the first one at the top. You copy the base and add the exponents. N plus m, it doesn't matter. If you write m plus n, same thing. So that's the first property. And this is the product rule. It's considered or called the product rule. Why the product rule? Because we multiply. Notice one thing, very important thing here. We copy the base. So copy the base. We do not do anything to it. We don't multiply it. We don't do anything. So an example would be 2 to the 4th power multiplied by 2 to the 10th power. When I simplify this, I will copy the base, and again, what happens with the exponents? Correct. So 4 plus 10 is 14. So this is the product rule. Is this clear? Second rule in line is the quotient rule. So one more time, product rule. Now let's look at the quotient rule. What happens when I divide? A to the mth power over a to the nth power.
Would they subtract?
Yes, I copy the base and I subtract. Always in this order, no matter what. From the exponent of the numerator, I subtract the exponent of the denominator. So this is the quotient rule. Quotient rule. An example. 10 to the 5th power divided by 10. I copy the base and I subtract the exponents. Can anyone dictate the exponents?
It's 5. Right, that's right.
Perfect. So this is 10 raised to the 4th power. That was the quotient rule, which is this, the second rule right here on your handout. Now the next one. Any questions? I'm going to let you pick problems from the book in a minute, but I'd like to go through the exponential rules, they're called, and then we'll practice all of them. Okay? So I'm building up to the next property. Let's say I have 2 to the 4th power over 2 to the 4th power. I don't know exponential rules, let's assume. I have no idea how to perform this. But I see that 2 to the 4th and 2 to the 4th are the same. So when I divide the same over the same, what should I get?
0.
1.
Exactly. And now let's say we know exponential rules. And the property from before says copy the base and do what with the exponents?
Subtract.
Correct. I want to write them. What do I write?
4 minus 4.
Exactly. But how much is 4 minus 4?
Nothing.
Correct. So 2 to 0. So this is what I wanted you to notice. Any number raised to 0 is how much?
1.
1. But there is an if. There is an if. Very important if. Comma. If a does not equal 0. So we can never say that any number, like I just said, any number raised to 0 is 1. Only if that number is not 0. Okay, so the correct statement is not what I said initially before I put the if. I said every number raised to 0 is 1. No. This is the correct statement. Every number raised to 0 is 1 except 0 raised to 0. That's not 1. Okay? Good. So that's the next property on the handout right here. So now we are going to look at the next property, which is the power rule. So a raised to mth power, everything raised to the nth power. It's very important to have a good command of these exponential rules. Everything we're going to study from now on in this course, and when you get to 012 in the summer, is based on these exponential rules. Okay, so this is like basic grammar for math, right? Like grammar for English, this is basic grammar for math. Okay, so please follow through. I copy the base, and the rule says, one more time, this is the power rule. Why? Because I'm raising an exponential notation to a power. For the power rule, we copy the base, and what do we do with the exponents, if you remember?
Multiply.
Correct. M multiplied by n. So here's an example. 3 squared raised to the 4th power. I copy the base, don't do anything to the base, and what happens to the exponents? Let's write them one time, and then, indeed. So this is 3 raised to the, very good, awesome. Very good. So this was the power rule. Now the next one. It's pretty similar to the power rule, but now I have, how many factors I have inside parentheses? 2 factors, very good. A is a factor, B is a factor. So when I raise a product to a number, I must raise each and every quantity or each and every factor to that number. So I have a to the nth power and b to the nth power. I don't have a name for this property. It's the power rule applied to a product. So that was this. And of course, the same thing we do with a ratio. So a divided by b, everything raised to the nth power. We raise the top to the nth power and the bottom to the nth power. Exactly as we did with the product. These are the exponential rules for now. We will add more at the end of this chapter. Here they are. More exponential rules on the back page. Not yet. Okay. On page 316 and page 317, please choose anything. Let's start slow. Let's say between 7 and 22. One more time, page 316. You want to choose or I will? Okay, I will. Let's say we have 14. And that is negative 4 raised to the 3rd power. Then I would like to look at 22. Negative 4 times 3 to the third power. And also 18. 18 is negative 1/9 squared. Okay, very good. So let's start with number 14. I see two factors there. Really? Yes, I do. Although you don't have to decompose them like this, but I see two factors. So when I raise negative 1 to the third power, what do I get?
It's positive.
When I raise a negative number to an odd power,
Yeah, -1.
always negative, yes. And negative, and then I have to raise 4 to the third. Or you can say, I don't want to decompose it like that. I don't want to think in terms of negative 1 times 4, but that's what it is. It's negative 1 times 4. I want to take negative 4 to the third power right away, which is fine too. I take a negative number to a third power, an odd power. I know the answer must be negative, and then 4 times 4 is 16. 16 times 4 is 64, and it's done. But remember, this is exactly what it means. It's a product of two factors. All negative numbers were obtained by multiplying the positive numbers by negative 1. And that's all it is. Okay, now what about this? How do I perform this operation?
Do the exponent first.
I do the exponent first, so I have to raise 3 to the third power. And 3 to the third power is,
27.
very good, 27 indeed. So from here, I continue negative 4 times 27. I multiply a negative number by a positive number. The answer is negative. So 28 and 10. Okay, this one. Again,
You multiply
yes,
both the exponent of both, like 1 and 9.
I erase to that power. Yes, correct. First, I want to deal with a negative because I don't want to make a mistake. So again, you can say, like we said it a minute ago, it's negative 1 multiplied by 1/9, everything squared. Or you say, I'm squaring a negative number. First, I have to deal with a sign. It's the safe way to do it. So what is the sign?
Negative.
Right, but after I square.
Oh, yeah.
I mean, of the final answer.
If you
It's positive, very good. And then 1 squared is, because I'm applying this rule.
It's 1.
Very good. And 9 squared is?
Yeah.
Very good. Is this okay? Perfect. Moving on to the next. Evaluate each expression given the replacement values of x. I like this. Let's say problem 28. So evaluate. These are all keywords. Remember 2 keywords that no, you don't remember because we haven't really talked about factoring yet. But I always try to simplify anything that I'm given. If it's an equation, if it's an inequality, my thought is, let me simplify it if I can. So this is another keyword we're asked to evaluate. And here's the expression in number 28. They're all on the same page, 316. And negative 4, x squared, y to the 5th. And they're telling us that x equals 2 and y equals negative 1. This is not entirely new to us. We've done this before. What do I have to do first?
Put 2 in x. And
Yes,
-4.
negative 4, I have to copy negative 4. 2 is a positive, x is a positive number, so I do not need to put in parentheses. It's not wrong if you put in parentheses, that's fine too. But here I have no choice because all these are multiplied. I have to put y, which is negative 1, in parentheses. I cannot have 2 operation symbols sitting one next to the other. I can only have the multiplication symbol and the negative, or the minus, sitting next to each other without having parentheses. I will not know what to perform. Do I perform the product? Do I perform the subtraction? So now I know it's very clear. After I raise to the 5th power, I must multiply. So I start with powers, of course, exponents. 2 squared is
2 times 2 is 4.
good. Negative 1 to the 5th is
Negative 5. Wait,
Negative one.
very good. So now, first I deal with the sign. I see a negative times a positive times a negative, but remember I can rearrange them the way I like. It's the product, right? I can start here, multiply here, and then come back. I can start here, multiply, because it's the product. If there were a division in here, I would have not been able to do that. But if they're all factors in a product, I can do whatever I want. 2 times 3 times 4 is 4 times 2 times 3 is 3 times 2 times 4. It doesn't matter. Same thing here. But first I have to establish the sign, so I don't have to forget about it, or I don't have to worry about it. What is the sign?
Positive.
Yes. So now I say 4 times 4
16.
times 1 because I already took care of the sign. So the answer is 60. Any questions here? Any questions? Now let's get to slightly more sophisticated problems, like 38. This was just a warm-up. 38. A squared b, in parentheses, multiplied by a to raised to the 13th power and b raised to the 17th power. Is there a need for parentheses here? Really? No, there is no need. Unless we had powers here, there is really no need for parentheses. You do not have to write the next step. You can do it, you can perform the next step without writing, but I like to write it once, at least. So because there is no need for these parentheses, I will write a squared times a to the 13th times b to the 17th. This operation can be done without writing it. So only because it's a product. If I had division, subtraction, or anything else, I could have not done this. But they're all factors. They're multiplied. So I put this in front here, and I move b. And now I know what to do. I copy the base. And what happens to the exponents? By the product rule.
Yeah.
Yeah.
Very good, yes. 15. Multiply by b. Product rule, copy the base,
18.
18. And this is the final answer. Notice one more time, we did not do anything to the bases. We just copied them. At this point, I cannot do anything because I don't have A, I don't have B. Okay. Let's look at 42. 42, we have 12, x to the 5th, and in parentheses, negative x to the 6th, times x to the 4th in another set of parentheses. Okay. Now here, I didn't really need parentheses around 12x to the 5th. I really didn't need parentheses around x to the 4th, but definitely I needed parentheses here because then I didn't know what to do. I would have not known what to do. Right? Am I multiplying? Am I subtracting? What am I doing? So first I need to establish the sign. This is a positive quantity. This is a negative 1 in here, and this is a positive. So what will be the sign when I multiply these three quantities? Definitely negative. Then I deal with the numbers in front. I see a 12. This was already taken out. It's 1 and 1. So 12 times 1 is? Very good. Now I'm multiplying the x's. But obviously I must copy the base. Don't touch the base, just copy it. And what do I do with the exponents? Well, depending on the rule. If it's the product rule, I add them. If it's the power rule, I multiply them. If it's the quotient rule, I subtract them. Which one is it?
Product.
Yes. So I have to say 5 plus 6, or better, 6 plus 4, which is 10, plus 5, which is 15. And this is final. Okay. Let's look at some geometry. Let's say 43. We're given a rectangle. And the rectangle has the width 4x squared feet and the length 5x cubed feet. We're asked to find the area of this rectangle and the measurement unit for the area. So this is measured in feet and this is measured in feet. Do we remember the area of the rectangle? The formula.
Width.
Yes, awesome. Length times width. Length times width. Perfect. So then I continue. The length is
5x
awesome. Multiplied by
4x.
very good. Do I need parentheses? They won't hurt, but I don't need them. Good. What do I multiply first? Because remember, I can rearrange these factors the way I want. But I always start with the numbers.
5 times 4.
Very good, which is
20.
perfect. And then I copy the base. And what happens to the exponents?
Add.
Correct. Very good.
Oh, 5.
That's it. Measurement unit for the area.
21x feet.
So let's discuss this. So when I multiply feet by feet, feet multiplied by feet, I copy the base.
Square.
Yes, I have to add the exponents. What happens if I want to determine the volume of this room? I multiply feet by feet by feet. I don't know, 12 by 12 by 7. 12 feet times 12 feet times 7 feet. Foot by foot by foot. Copy the foot. What is the power?
3.
That's it. That's why volume is measured in blah blah cubed. That's why area is measured into whatever squared. If it's inches, if it's feet. Is that clear? Okay, perfect. Let's look at a circle, 62. Let's see what they want with a circle. Given the circle below with a radius of 5y. So radius, 5y, and they measure it in centimeters. Find its area. Do not approximate. So this is a circle, and this is 5y. They want us to find the area of this circle. Anyone remembers the area of the circle? Pi r squared. What will be the measurement unit? When I square 5y, which is in centimeters. What did we say the area is measured in?
Centimeters.
Squared,
That's
right? So whatever it is, it has to be because I'm multiplying. So when I square 5y, I have to square centimeters. So the area is pi, and in parentheses, I have no choice. I need parentheses, otherwise, I would not know that I have to square 5, and I would have to square y. Okay? So what do I do now? I copy the pi, and okay, we're here. So we just finished this, and we're working on problems in the book. Okay, so a equals pi times,
Do you use 5y times by 4? Can you,
Yes, but we have this property that we want to use. 5 to this power times this to this power. This is the property we want to use now. But you're right. 5y times 5y is fine.
Would it be 10y squared?
But 5 squared is,
25?
yes.
Y squared.
I know it's tempting to multiply this by this, but that's not the case. That's not what we're trying to do. I know it's tempting. That's why I'm trying to prevent that. So the way we rearrange this, they want us not to approximate. So I'm only going to rewrite 25 pi y squared, but I need the measurement unit. One more time, the measurement unit for the area of the circle must be?
Centimeter squared.
Very good. Okay, so let's look at a cylinder now. And this is 64. So here's a cylinder. Good. And they say the silo shown in the shape of a cylinder has a radius of 4x meters. So this radius 4x meters. Okay. And its height is 5x cubed meters. So here's the height. 5x cubed in meters also of course. Find the volume. How do we determine the volume of a cylinder? Here's a cylinder. Area of the base. What is the area of the base?
so maybe, no,
Circumference.
No, the area of the base. We just worked on it 3 minutes ago. What is the area of the base of a cylinder?
Pi r squared.
Of course, it's a circle, right? Pi r squared times the height. So pi r squared times the height. That's the volume. So always remember, area of the base times the height. Good. So the volume then is pi times, how do I write it?
R squared. 4x.
4x everything squared multiplied by
5x cubed.
5x cubed. Awesome. Now let's take it slowly and tell me what to do next. What do I have to do next? I copy the pi. What else?
Multiply 4 by 4.
Awesome, which is 16 times
5 times 5 times 5. We gotta do this. It's x squared.
very good times.
5 times 5 times 5.
This is not 5x cubed. It's 5x cubed. There is no connection between 5 and the power 3. That's why we discussed.
If it was in parentheses, though.
Yes.
Oh, okay.
Yes. See, here 5 has power 1. I cannot just say, okay, let me transfer this power from x to 5. I cannot do that. So this is 5x cubed. Now I will multiply 16 by 5 and put it in front of pi. What do I get?
80.
Very good. Indeed, 80 pi. Now I have to multiply x squared by x cubed. Copy the base. What happens to the exponents?
Right.
Very good. I get?
5.
Good. Measurement unit, please.
I don't remember what you said. Meters,
Meter squared.
What did we say about the volume?
meters cubed.
Meters cubed. So when we talk about the volume, we are multiplying one more time. Meters by meters by meters, right? So area of the base is already meters squared. Times another meter, we get copy the base and the exponents. Is that okay? You understand the volume means 3 dimensions. The area means 2 dimensions. If we measure the area in meters squared, we cannot measure the volume in meters squared. Is that clear? Is that a yes?
Yes.
Okay. Good, so let's look at 52 now, which is a to the 4th, b, everything to the 7th power. And then I would like to look at 60. And then I'm going to ask you if you think that this is enough and we can move on. Or we can still work on problems here. This is so important. Ready? So I have a to the 4th times b. How many factors I see in parentheses?
2.
And I have to raise both to the power 7. Copy the base. What happens to the exponents? Correct. And the power is?
28.
Very good. Then I copy the base, b. And I do what with the exponents?
Multiplying.
Yes. 7 multiplied by? Right. Is 7. Good. The next one. Okay. So xy to the 4th over negative 3x to the 3rd. I would normally say, make sure you completely simplify in parentheses. There's nothing I can simplify because they are not common factors that I can simplify. This is x, this is negative 3 and z, this is y, negative 3 and z. They have nothing in common. So I have to simply raise each and every factor to which power again? To the power 3. So I copy the base and I get what?
3.
Very good. I copy the base and I get,
7.
I know it's tempting.
Oh, you multiply.
Yes.
12.
Negative 3 to the 3rd power. What type of number would that be?
Yeah, negative.
Negative 27.
Awesome. Times z to which power?
1. No. I'm sorry.
No problem.
3.
9.
9. The only thing I have to do is realize that the top is positive, the bottom is negative. The sign goes in front. Mandatory. This is not fully simplified. I have to put the sign in front. So x to the 3rd, y to the 12th, over 27, z to the 9th. Any questions? Okay. 80. Negative 3 raised to 0 plus 4 raised to 0.
2.
Not so fast.
Actually,
First thing we have to do is realize that this, again, is negative 1 multiplied by 3 raised to 0 plus 4 raised to 0. Why? Or I shouldn't write, oh, anyway. I didn't have to write that again, but I put the equal symbol now. I fixed it. Why? Because I don't want you to think that this is the case. Negative 1 and 0 do not touch. They have nothing that connects them. Bless you. So how much is 3 to 0?
0.
Yes, it is 1 as long as 3 is not 0, but 3 is not 0.
Correct.
I agree. So negative 1 multiplied by 1 plus
Okay.
4 raised to 0. 1. So now I multiply negative 1 by 1 and I get n plus 1, and the answer is, that's it.
So any power raised to the power 0
No,
is
any number
any
raised to power 0. We wrote it before.
Yeah.
It's right here.
Yeah.
It's right here. Any number raised to 0 is 1 as long as the number, the base, is not 0. 0 raised to 0 is not 1. You have to wait till Calc 1 for that. Okay, next one. Let's say 79. 5 raised to 0 plus y raised to 0. 5 raised to 0
Is 1.
plus y raised to 0.
Y. Is it Y or 1? Wait.
This one,
Yeah.
y.
No, I'm asking if it's right.
Do the same rules apply to the variable?
Everything.
Oh, okay.
That's why we practice them, and that's why we look at this. Yes. The same rules apply. Very good question. The exponential rules are valid if the base is a number, or if the base is a variable, or if the base is an expression, a combo of variables, a sum, a difference, whatever. The exponential rules are valid forever, no matter what the base is.
Is the answer not Y?
That's what
One.
Yes, it is 1, of course.
Oh.
Any number, any base. That's why Corey was
So what
asking.
if Y was equal to 0?
I have to write if. I'm going to continue and say,
Oh.
of course, of course, I'm going to write 2. Only if y is not 0. Yes, of course.
Okay.
I have to write that. You're right. Only if y is not 0. Very good. How are we doing so far? Okay, so I'd like to look at also 68 and 70. 68. Negative 6 raised to 13 over negative, oops, I'll erase that, over negative 6 raised to 11. Sorry about that. Good. So any suggestions here? Any suggestions?
Did you subtract the exponents?
Yes, I copy the base.
Yeah.
Yes, very good. I copy the base and subtract the exponent.